Hello everybody, my name is Paul Fenton. I'm the CEO of Montrium, and we're very happy to welcome you to the second edition of this webinar. We obviously gave this webinar around a month ago and it was very popular, and so I know that some of you couldn't join during the last session because we ran out of places, so we're very happy to see that you were able to make this session. Before we get started, just a few housekeeping points. If you have any questions, feel free to enter them in the question panel. We will try and answer them at the end of the webinar if we have time. We'll also be outputting a blog with questions and answers because the last session already generated a lot of questions. And so that will be published on our website, and we'll be sending you a link to that as well once we publish it. So let's get started. How to build and qualify the cloud for regulated applications. So today I have two of my colleagues, Gianna Durabertis and Sam Collier, who are going to be presenting on this particular subject. So just to introduce them, Gianna is our Director of Professional Services. She's been working here at Montrium since 2008 and has quite a lot of experience within the pharmaceutical industry and specifically within validation and compliance of systems. Joining her is Sam Collier, who is our Product Integration and Deployment Coordinator. And Sam has been with us since 2010. He's got a scientific background but also a very, very strong systems background. And Sam really leads a lot of the efforts here at Montrium around Microsoft Azure and how we use Microsoft Azure not only for our own platform but also for some of our clients' applications as well. So the focus of today's webinar is really, it aims to be practical. We're going to be talking a lot about how we've actually used Azure for our application, which is a regulated application, and hopefully give you some insight into the best approach for tackling something like this. So we'll have a few slides on what is regulated cloud, why we chose Microsoft Azure, and what did we qualify it for. We'll then talk about the actual approach that we took, both the technical and the procedural steps that we took, and then how we actually realize benefits from what we actually put in place. And then finally we'll finish up with the conclusion and some recommendations for you all. So there are many factors which are pushing the pharmaceutical industry to adopt new strategies for computerized systems. The regulators are also changing and evolving when it comes to computerized systems and their expectations. I think three of the most important factors are, first of all, obviously the patent cliff means that we need to do more with less compared to the golden years. We also have more pressure nowadays to improve traceability and transparency in relation to clinical trial operations and things like that. And then finally, I think personalized medicine is really changing the landscape as well. We're having to do a lot more clinical studies. We have smaller populations, more targeted populations that we're targeting. And this introduces a lot more granularity and therefore a lot more complexity, which really pushes us to try and find computerized systems that can help us manage that new complex environment. Now, new computerized systems doesn't mean to say that we don't need to meet the same standards in relation to quality, compliance, and then of course agility and flexibility. We still need to have that. I think cloud computing in all aspects of our lives today is really taking center stage, and that's why of course the pharmaceutical industry is also now looking more and more towards cloud computing, and this really introduces a new IT paradigm that we need to embrace, and of course a lot of the regulations that we're following are still quite old and not necessarily aligned with this new paradigm, and so that's really the challenge at hand. Cloud computing does provide us with an opportunity. It can be cheaper than more traditional IT infrastructure. It's a lot faster, it's more scalable, it's more highly available, and also, and this is very important, it provides us with better disaster recovery capabilities. And that's very important, of course, because the data and content that we generate within life sciences is extremely important. It's the foundation for everything. One of the issues that we have is that there isn't really any clear regulatory guidance yet, but I do know that the regulators are actively working on trying to establish clearer guidance when it comes to cloud computing. There's also some initiatives with GAMP where the FDA is involved in trying to take the existing GAMP framework and then adapt it to cloud environments. The dilemma that we have, and we've always had this dilemma in the pharma industry, is innovation versus compliance. And there is a lot of innovation going on at the moment within IT and within pharma as well. But of course, we always still need to maintain compliance, and that's really what the focus of our webinar is today: is how do we actually demonstrate compliance? So some of the challenges that we have in relation to compliance is, well, first of all, the industry has typically been very risk averse in relation to computerized systems, and we've typically overdone things in the past, and we actually have a hard time trying to take the cloud, which is really a series of machines, and put that into the existing compliance framework. We have also a very specific set of requirements which are defined in things like 21 CFR Part 11 or Annex 11, or even computer systems used in clinical investigations. And they are specific to the pharma industry, but a lot of the cloud providers that we would work with are not necessarily working just within our segment. They're working across industries, and therefore they may not be using the same terminology or may not even have the same controls as we typically have. Traditional qualification is also focused very much on individual machines and specific hardware and software. We need to be able to clearly identify what is it that we're using to install our applications. And when it comes to cloud, that obviously changes. We have a cloud fabric, which is made up of many, many different hardware components, and we have to be able to take that fabric and demonstrate control and demonstrate that we can properly qualify it. We have to be able to clearly identify and document those system components, and that's really the big challenge here, and that's where we need to have a change in thinking when it comes to cloud. We're also, of course, sharing resources. If we're working with a public cloud, it's shared resources, and that's what obviously makes it much cheaper than traditional environments. The problem with this, of course, is that the ownership's not very clear. Who actually owns what machine? That's not an easy question to answer when it comes to cloud, as well as who's responsible for what. That also needs to be very clear. And then finally, change control. We're not always in control of when changes happen when we're in a cloud environment, and so we need to think very carefully about that and work out ways and processes for ensuring the validated state, for example, of our systems once change control occurs. So this new paradigm that we were talking about, obviously we have a cloud environment which is out there somewhere, and within that environment we have different actors. We have the cloud vendor, we have SaaS vendors, so these are typically organizations that are providing a solution which is deployed on the cloud, and so Montrium, for example, is a SaaS vendor, and we provide our Montrium Connect solution on Azure, so Microsoft's cloud. And then finally we have the users, so the pharma company, and all three of these organizations have a role to play. Now the cloud vendor, of course, has a whole series of hardware components, and those components really need to be thought of as one large machine. So if we're thinking about qualification, we really should be looking to qualify the cloud as one large machine rather than individual components. Each of these different actors also have very specific roles and responsibilities, and these roles and responsibilities need to be clearly defined, usually in the form of quality agreements or and SLAs. Afterwards, each of them will also have a certain number of controls, and these controls are typically procedural and technical, and we need to clearly understand which controls are where. And then finally, we have to be able to demonstrate those procedural and technical controls to the regulators, so FDA and EMA, among others, of course. So this is really the new paradigm that we're working in within a cloud environment. So why did we choose the cloud at Montrium? First of all, we chose it because it allowed us to deploy our applications very, very quickly, and that really is a game changer compared to traditional on-premise deployments where we would have to go through a lot of qualification activities. The cloud also gives us very flexible pricing models. We only pay for what we need, and that's really important, and we're able to pass those savings on to our clients as well. It allows us to scale significantly and very quickly, and that's really important, especially when we're dealing with very sort of data intensive applications where we're storing a lot of information. We have to be able to scale easily, and not only in storage but also in processing power. It allows us to introduce operational efficiencies in the way that we actually manage the whole environment, and it reduces CapEx because really we're just subscribing to a service, and that can be useful from a financial accounting standpoint. It can alleviate internal IT burden because, of course, some of the activities that are required to maintain these environments are actually being provided by the cloud vendor. Not all of them, though, and it's important to remember that. And then finally, it improves availability because typically if we're working on a large public cloud like we do with Azure, they have many different data centers, and we can introduce significant disaster recovery capabilities, which we could never really do with our own smaller data center. So we chose Azure because obviously we work globally, and it's important that we have data centers worldwide. Notably for Europe, of course, there are lots of confidentiality rules that we have to deal with, and having the ability to set up data centers locally in Europe was very important for us. They also have significant capacity. Obviously, they're one of the main cloud vendors out there, and they're certified through ISO and SOC, and this is very important because it's a very integral part in our qualification approach. Our team here at Montrium is also trained and certified on that technology, and so that was also so important. We had to make sure that we could actually properly manage the environment. The pricing is competitive. Cloud really is a commodity at this point, and also we had existing knowledge through a white paper that we authored with Microsoft several years ago on how to approach compliance with the cloud and Azure. And so we used that existing knowledge really to give us a head start on how to go about qualifying and using this environment. So finally, the approach that we took when we actually set up our Azure environment was, first of all, we had to define what were our needs, what was the architecture that we needed, what did we need to support our applications. We then implemented a certain number of controls internally to be able to use cloud. We then did due diligence on the vendor, and so that involved obviously evaluating what they had in place and the different controls they had. And then finally we qualified the environment. So at that point we had an environment in place. We were then able to migrate our applications, and we're now in the monitoring phase where we're actually maintaining that environment and ensuring that it's running smoothly. So with that, I'm now going to pass you over to our first speaker. So Sam will now start to go through some of the steps that we went through to implement our environment.
Thank you, Paul. So hello everyone, my name is Sam Collier, and I'm going to be talking to you a little bit today about the technical approach we took when we were qualifying and building our cloud. So the diagram Paul showed before showed the different phases we went through, and the very first was defining our needs and really looking very carefully at the risks with going to the cloud. Of course, we knew we wanted to go to the cloud, but it was important to really define this step and be very, very clear about our requirements and risks so that we could really have a successful project. So of course there were the obvious advantages. We were looking for a flexible, highly redundant infrastructure to deploy our applications on. We knew that from the start. But as we looked into this in more detail, we started to come up with additional requirements that really would make the cloud really a strong move. And one of those was security. Now whenever we talk about cloud, security is almost invariably the first question that comes up. So right from the get-go, early on in the process, we decided that we didn't want to have a cloud that compromised security, but rather we wanted to have at least the same security we had in a private cloud, and if possible, leverage cloud technologies to make the system even more secure than a traditional on-premise deployment. Of course, we also work very closely with Microsoft technologies, so support for the Microsoft technology stack, which is Windows Server, SharePoint, and of course our Montrium Connect applications was a must. The other important aspect for choosing a cloud for us was we really wanted a transparent cloud framework. Because we needed to perform qualification and validation activities, simply having a black box wasn't quite enough for us. We wanted to have some visibility on our data. Where is it located? What configuration is supporting our deployments? And we wanted a level of control that really allowed us to meet the compliance with regulations that we needed. So we had already worked with Microsoft a little bit and had the Microsoft cloud stack in mind. And as we got into our requirements, we started to look at a few more of the options. Now with Microsoft, they have a comprehensive cloud platform at every level. The first level is SaaS, which I'm sure most people are familiar with. That's software as a service. A great example of this is the popular Office 365 platform. It's an application that's available on the cloud for general use. It's great, quick, easy to set up. However, really only allows very minimal customizations and has a very low level of control over the application. So relatively early on in the process, we were able to rule that out as an option. As we moved down the cloud technology stack, we looked at platform as a service. Now, platform as a service isn't quite as popular as SaaS. It's when the cloud provider provides a data platform for a third party to provide an application built on top of. Now, at first, this was very interesting. A great example of this is the popular Azure SQL platform. However, particularly at the time, as we investigated, there was quite a few limitations for application support, security, encryption that really didn't quite meet the requirements we had set out. Going further down at the lowest level, we have infrastructure as a service. Now, infrastructure as a service essentially allows the cloud provider to give you a portion of infrastructure of their highly redundant global infrastructure of data centers, and to provision cloud services, virtual machines, servers, all in this flexible fabric. So looking at these and after doing our analysis, we decided on the Azure infrastructure as a service. The reason for this was quite simple. It still provided the ease of management and scalability and security we were looking for, but it allowed a lot of flexibility. We could move our applications to the cloud while still maintaining our legacy data centers. Now, this was a really important aspect for us. We weren't setting up a brand new cloud platform. We already had an existing private cloud with an existing user base. And one of our requirements was that we didn't want to impose any restrictions on existing users. We wanted the process of moving to cloud to be completely transparent. That meant no change of login credentials, no change of emails, nothing like this. And the infrastructure as a service really allowed us to do this. The reason this allowed us was the ability to do a hybrid cloud approach. Now, for anyone who's not quite familiar with the terms, a full cloud is when you move entirely all of your infrastructure and applications to cloud-only solutions. Now, this is a great approach. This is great for brand new environments. You don't need any existing infrastructure or any capital expenditure to get started. You can basically spin everything up and hit the ground running. For us, however, we already had a qualified data center, already had a private cloud. So a hybrid cloud allowed us to keep our existing validated environment and components and extend onto the cloud without having to decommission anything or providing any interruption for existing users. So once we had decided on our platform, we decided on the Azure infrastructure as a service, we began to dig into our risks. We knew that there were some risks with going to the cloud, such as authentication. How do you know who someone says they are? Compatibility with third-party applications, as well as the general paradigm shift to moving to the cloud as opposed to an on-premise. Will documents still work? Configuration specs, having the same values. As we started to get into these and develop our risk assessment, we realized before we could write a really thorough risk assessment, we needed to prove that we could mitigate all of the high-level risks. So this led us to a very important stage, which was the proof of concept stage. Now, this was absolutely essential as the cloud presented challenges that required configuration updates and, quite frankly, to become more familiar with the cloud environment. So some configuration, although we think of the cloud as fully configurable, can only be done on the initial provisioning process and can't easily be altered afterwards. So although we think of the cloud as being completely flexible, completely elastic, there are some cases where when you configure your cloud, you need to be cognizant of what it is you're configuring. We mentioned that we wanted to have visibility on physically where our data was located. And while the Azure infrastructure does the ability, something that needs to be planned from the onset, otherwise it can become quite difficult to change. We also went through in our proof of concept and developed documents such as our cloud configuration specification that allowed us to really document and control our cloud environment. When we were doing our proof of concept, we actually encountered additional items as we got into the system that were really critical in developing this robust risk assessment that we had gone through in planning. One of these was actually performance profiles in the cloud were different than on-premise. Now, when I talk about performance profiles, what I'm talking about is how a machine interacts with a particular application. For example, in a traditional data center, we're used to a server that may be 2 or 3 years old and has a processor as such, but being as the disks are located in your central, all in the same location, access to those disks can be very fast. Now on the cloud, it's a little bit different even though it looks equivalent. You have the latest processors, often by Intel or AMD. However, your storage, by nature of being cloud storage, isn't always next to your server. So it can introduce a little bit of a performance difference that needs to be accounted in your configuration of the cloud. And that was one of the things that this proof of concept really allowed us to tweak. It allowed us to optimize the performance of our applications in the cloud to really get the most out of what we were expecting. Additionally, there was also specialized knowledge for managing automation. Now, when we talk about cloud, automation is actually key to making the cloud as elastic and flexible as people hope. Now, one of the great things is the Azure infrastructure allows for this type of automation and scalability. However, anyone who's worked with it knows that it does take a little bit of specialized knowledge. There's, to date, roughly about 300 PowerShell commandlets to configure your environment, as well as an interface that allows more and more options almost by the week. So gathering this specialized knowledge really allowed us to take advantage of the cloud. Our final instance of using our proof of concept to enhance our approach was being able to drive on our dev test prod approach. Now in the life sciences, we're used to an IT environment where we have an uncontrolled environment, typically referred to as dev, a staging environment, and a real live production environment. Now this is a very robust approach. It allows you to have a very high degree of assurance that your applications will work as intended and to execute very tightly controlled change control procedures. Now in the cloud, we can absolutely continue with this approach. However, we actually gain some advantages. Rather than in the physical world needing to buy a dedicated server just for your uncontrolled development environment or staging environment, you can actually turn these on and use them as you need. And when they're done, you can deprovision and keep your same configuration. So what this allows is for you to maintain that really robust dev test prod approach, that 3-tier approach, all of the benefits really for less costs, which is just a great advantage. And finally, this allowed us to really adapt to the cloud. There was new components, new configuration, regions, and upgrade domains and things that we'll talk about later on that we really optimized to make our system really cloud ready. Now, that cloud infrastructure simplifies the provisioning. However, automation, as we developed in our proof of concept, really made the project a complete and total success. So at this point, we have developed our proof of concept. We decided on our platform as Azure Infrastructure as a Service, and we'd begun to write our risk assessment. We had all of the knowledge that we required to do a really detailed risk assessment. And once we had this, we could start to identify appropriate internal procedural and technical controls to help mitigate all of the risks in the cloud. So of course, with any system, a risk assessment is a critical document. And as we were identifying the risks, we identified both procedural and technical controls to mitigate those risks. Now, technical controls are required to implement system-level measures. These are things that people typically think of as firewalls, audit trails, the enforcement of username and passwords, really system-level controls that block activities that are unintended. And these are pretty straightforward, and we'll talk about them in a little bit more detail. But it's important to note that we also have procedural controls even when we're talking about the cloud. And a great example of this is verification of backups. So you can have a great technical control for automated backups, which is of course a must. However, a perfect example of when a procedural control is required would be verification of those backups. It's very important to recognize that backup and disaster recovery, as it's often returned, isn't really backup, it's restoring. And so testing those backups and the validity of those backups is a great example of procedural control that's still very applicable in the cloud. Of course, you also have change control and the like, and we'll talk about those in just a minute. So I want to get a little bit into the technical controls that we put in place when we went onto the cloud. And we mentioned at the beginning that we were really looking to have a cloud that enhanced security rather than make any compromises on it. And one of the ways that we managed to look into and actually achieve this was using something called two-factor authentication. Now, two-factor authentication, for anyone who doesn't know, is when you need two separate pieces of identification to access a system. In this case, it's actually a username and password, and in addition, something such as a mobile device, either a text or a phone call, to ensure that you can authenticate. And we were actually able to implement this robust authentication not just for management interfaces, but actually any management interface, whether it was web portal or command line, any sort of administrator accessing the system is actually controlled with this authentication mechanism. We are also able to use the Azure Infrastructure as a Service to really control the flow of data in and out of the system. So although it's a public cloud, we can still control the flow of data through a specific proxy, through a specific portal, and direct connections just randomly off the internet are of course not allowed. And it allowed us to configure additional firewalls and access control lists to really put in place tenant isolation as well as secure it from the internet. Finally, of course, we have end-user authentication where we have logical security, standard operating procedures and controls that enforce things like lockouts after a certain number of bad password attempts, isolation and delegation of authority. And these are the same types of standard password controls you would see in an on-premise environment that we were able to put exactly into a cloud as well. Now, for procedural controls, we were actually somewhat surprised. Many of the procedural controls required only minimal modification and adaptation from standard on-premise controls to work in the cloud. Things like change control and logical security. You still need to document your changes. You still need to control configuration, whether it's the cloud or on-premise. These were pretty much the same. However, some of them, like disaster recovery, really had to be dramatically rewritten for the cloud. A great example of disaster recovery is in the cloud, you have, for example, a virtual machine, and the virtual machine's disks are triply redundant. That means there's 3 copies of your data. Now, in addition to that, you can configure backup procedures that back up your data to a different geographic region, which would be off-site backups. And even in addition to that, through these procedural controls, you can have what's called off-cloud backups, where your backups go to a traditional off-site data center. And these are some of the procedural controls that we identified to really keep the platform under control. And finally, the last step would be simply new work instructions. The cloud does present a different way of working, so that means different instructions for deploying applications and managing applications on the cloud versus on-premise. And so with those, we identified all of our technical and procedural controls to really go ahead with our qualification effort. And with that, I'm going to hand it over to my colleague Janet to talk a little bit more about that qualification effort.
Thank you, Sam. So I'll now continue speaking about the next step in building and qualifying Azure for regulated applications, which in this case is to perform the cloud vendor due diligence. Specifically, in our case, the cloud vendor is Microsoft. So the task of qualifying Microsoft for us was actually really simple because we had previously worked with them directly on other projects. One of the things we did with them was to publish a white paper called Qualification Guideline for Microsoft Azure. And the purpose of this white paper was to provide guidelines that assist life science companies in establishing a qualification strategy for Microsoft Azure. The guideline is founded on the fact that Microsoft has been audited by other independent third parties through who these third parties have confirmed through various certifications and audit reports that Microsoft follows best practices for information security management systems and the security standards for security service organizations. Any existing Microsoft customer can request access to these certifications and audit reports subject to the terms and conditions of non-disclosure agreements. And that's exactly what we did. We requested copies of those certifications and audit reports from Microsoft, and we reviewed them internally. Basically, we looked for things that we can map to Part 11 and to Annex 11. So we didn't do any postal audit, we didn't do any on-site report, we simply reviewed the available documentation. And then we followed our internal vendor management procedure to document our findings of the review. We used our vendor assessment form to document our findings, and in the end, because we were satisfied with what we found, we essentially qualified Microsoft as a vendor for us. Our intent is to repeat this process periodically just to make sure that Microsoft maintains its certifications and continues to respect the quality standards. This is important because the certifications and audit reports are only valid for a fixed duration of time, and they would need to be reissued periodically. And so from our end, we want to make sure that they are on top of their game. So the outcome of the vendor assessment, in conjunction with the proof of concept that Sam spoke about, allowed us to move forward with the project, and that's when we began the qualification phase. So let's take a look at our qualification exercise. Fundamentally, the purpose of qualification is to demonstrate regulatory compliance, and the overall approach, theoretically, is really not that different when qualifying on-premise versus infrastructure, cloud infrastructure. Our qualification approach includes 5 steps. The first step is to document a risk assessment. Then we documented a qualification plan. Then we documented specifications. Then we documented the verification and testing activities. And finally, we reported the qualification effort through qualification reporting documents. I'm emphasizing the fact that we're documenting every step because if it's not documented, it doesn't exist. That's just the nature of our world. So let's look at each step in more detail, beginning with the risk assessment. Earlier, Sam discussed the risk analysis that was performed and how it was pivotal in making design decisions and configuration choices. The risk analysis contributed to the qualification effort in that it was the first step in the process of qualification, and it's at this point that even though we started risk analysis earlier on, it's now that we actually started formally documenting it in an approved document. The purpose of the risk assessment is to identify and manage risks that arise from failure of the system functions or components. We followed GAMP5's methodology for the risk assessment, and we performed the following steps. First, the technical team, business analysts, and quality representatives came together in a team effort. It's important that a lot of people came together in a team effort to collectively identify GXP risk areas. For each risk area, we identified possible risks and risk scenarios. And then for each risk, we assessed 3 factors: potential harm, likelihood, and detectability. Then we performed some calculations. We calculated severity as the product of harm times likelihood, and then we multiplied that by detectability to give us a risk level. Ultimately, we want the risk levels to be as low as possible. So our last step was to describe what measures we already had in place in order to mitigate the risks to an acceptable level, which was low or medium, and furthermore, we brainstormed for additional actions that we can put in place in order to bring the risk level even lower or to a more tolerable level. The risk assessment document looks like this. It's a big table with a lot of information, and here we see two examples of risk areas and risk scenarios. The first risk pertains to data backup and the possibility that there would be complete loss or corruption of data. For this risk, the risk level is low because we know that we have a backup and restore procedure in place, and this procedure oversees the offsite backup process. This for us was considered to be enough of a control to lower the risk, and so we decided that no additional activities were required for this particular risk. In contrast, the second risk that you see here pertains to data storage and running out of disk storage space. To minimize this risk, we decided that we needed to monitor our system for disk usage more carefully, and for this we needed to update our system maintenance procedure to include that particular task. So the risk assessment is a really big table that contains a lot of information, and it captures input from a lot of different people, technical and regulatory-minded people alike. But this exercise of documenting this risk assessment was really important, and it's the first step of the qualification, and because it's the first step, it shaped the entire qualification effort. And because of this, we can say that we're following a risk-based approach to qualification. This risk-based approach is described within the Qualification Plan. The Qualification Plan is a document that describes the scope of qualification, required resources, including roles and responsibilities, and the QA activities and deliverables that constitute the qualification effort. Execution of the activities described in the plan would generate objective and documented evidence that the Azure platform has been installed and configured properly and that it functions according to specifications. What does that mean? It functions against specifications. Which specifications are we talking about? Well, that leads me to the next step. In order for us to demonstrate that the system functions according to specifications, we first have to define those specifications. And we did this through a number of different documents. The first specification document is the requirements. The purpose of the requirements document is to define what Azure infrastructure has to do for us in order to satisfy our business needs and how it should function in order to comply with applicable regulations. We considered business requirements, functional requirements, and also security requirements. At the bottom of the screen, you can see some examples of the requirements. As you can see, each requirement is identified with a unique identifier, and that's to facilitate traceability later on. You'll also notice that the requirements are not very elaborate. We try to keep them short and simple, and that's just because the simpler they are, the more direct and easy it is to verify them later on. The next specification we produced was the system description document. As mentioned earlier, we qualified Azure for Part 11 and Annex 11 compliance as well. And because Annex 11 calls out for it, we produced the system description. This document describes the main components of Azure infrastructure and the interconnectivity of the components as well. In order to facilitate reading of the document and to make it more comprehensive, we included a network diagram. We just included it as an appendix and keep it up to date whenever we make changes to it. The last specification document is the configuration specification. This document serves to define the configurable system parameters outside of operational data and their assigned values that would allow the infrastructure to operate as intended. The format of the document is a big, large table, and we opted to use Excel to create this table. In it, we captured all of the configuration parameters and their assigned values which we specifically selected on purpose in order to allow us to meet the specified requirements, in order to allow us to reduce the risks that we identified during the risk assessment process, and also to allow us to leverage whatever knowledge we had acquired during the proof of concept. Each configuration parameter, like the requirements, is assigned a unique ID, and that also is to facilitate traceability later on. Now, looking at this, it's clear that the configuration specification is a large, intimidating document, but that's simply because Azure by nature is complex itself, so the configuration specification reflects that complexity. Regardless, though, it was incredibly important for us to create this document because this is what the technical team followed when they built the controlled environments, both test and production. And moreover, it's this that served as the basis of the verification and testing activities. Verification started with installation qualification, or IQ. The IQ was governed by an IQ protocol, which oversees the execution, documentation, and acceptance criteria for all the testing needed to demonstrate that the infrastructure components are installed and configured properly. The IQ protocol oversees a series of test scripts. The first one is the biggest and most important one that we executed. It's the infrastructure configuration verification. Because of the novelty factor of not having worked with Azure before, we opted to be conservative with this test script. So we literally verified every single specification in the configuration specification document. And moreover, we also took screenshots of the specific specifications as objective evidence that they were configured properly. Another test script that we performed was the standard operating procedure verification. And this one was important because during the risk assessment, we identified some procedural controls that needed to be put in place in order to mitigate risks. So it was through execution of this test script that we checked and confirmed that whatever SOPs we said needed to be updated were actually updated by. And lastly, we performed a system documentation verification. In this test script, we just took this as an opportunity to capture a snapshot of the service level agreements and other technical documentation available from Microsoft. Following the IQ, we performed operational qualification, or OQ. And just like the IQ, we prepared an OQ protocol to oversee the execution, documentation, and acceptance criteria for the testing. The testing necessary to demonstrate that the infrastructure functions according to specifications, or more particularly the requirement specifications, and that it's fit for its intended use. The OQ protocol, just like the IQ, oversees a series of test scripts. In OQ, we focused on verifying basic connectivity to servers and other high-risk security areas, both through positive and negative testing. We verified things like the multi-factor authentication process, as well as critical firewall features, to make sure that traffic that's supposed to pass through was allowed to pass through, and traffic that should be blocked was indeed blocked. We also verified things like controls for password management, and verified that these kinds of things complied with our internal policies. For example, we verified things like the fact that Azure can enforce the use of complex passwords. So we did encounter some issues during our testing. Some were attributed to documentation errors, but some were actually technical in nature, and it forced us to reconsider and adjust our configuration choices. So once we made the changes in the configuration in the system, we also updated the configuration specification document to make sure everything was synchronized. So upon completing the IQ and OQ, we moved on to qualification reporting. This phase of the qualification project started with completion of the traceability matrix. The traceability matrix serves two purposes. First of all, it confirms that the requirements that we documented in the requirements document are actually met. The second reason was to confirm that the controls were implemented to manage the risks as we had set out to do through the risk assessment process. So what we're seeing here right now is an example of how we mapped specified requirements to test scripts and procedures which verify those requirements. As you can see, it's not always possible to demonstrate through IQ or OQ that a requirement is actually met. And so in those cases, we provided rationale for not performing any testing. Most often, the rationale was to explain that that requirement is technically controlled by Microsoft. And since Microsoft is managing it, we don't have access to verify it physically with our own eyes. However, we're comfortable with this justification because we performed our vendor assessment. And I'm saying this just to emphasize the importance of doing that vendor due diligence. The fact that we performed that due diligence and documented means that we have something on file that says we went through that exercise and we're comfortable with the work that Microsoft is doing. And so we're okay to offload the responsibility onto them. So the fact that we have the due diligence certificate on file gives us something to leverage. So it's really important to not skip that step. In other cases, it was easily possible to verify the requirement with our own eyes, I guess, internally. And in those cases, it was easy to provide a cross-reference to the test script that was used to do that. So the second purpose of the traceability matrix was to confirm that the controls were implemented in order to manage identified risks. To do this, we pulled the risk mitigation activities defined in the risk assessment document, and we provided a cross-reference to the IQ or OQ test script that demonstrated that that activity was implemented or achieved. Finally, the last deliverable that we produced was the qualification summary report. So this document confirms that all the activities we set out to do according to our initial qualification plan were actually completed. So we confirmed that the required deliverables were produced, and we did this by providing a cross-reference to the document title, document ID, and the document approval date. We also summarized the execution results from the IQ and OQ test scripts. We mentioned which ones passed, which ones failed, and when we had issues, we provided a summary of those issues that we encountered along with the resolution. The conclusion of the report includes a statement about acceptance for use, and the report was approved prior to allowing infrastructure, Azure infrastructure, to be released for operational use. And with that, the qualification phase was completed and the system was handed over to the operations team, as Sam will continue to discuss now.
Great, thanks, Janet. So that's a great point. So at this point, just as a quick summary, so we've done our planning phase, we had chosen our vendor, we had chosen our cloud platform, and we've done all of our qualification efforts and configured the system. So now at long last, it's finally time to start actually migrating our activities onto the cloud. And this was actually where we started to see some of the fruits of our labors in terms of the extensive planning and risk assessment that we had done. So because of the approach that we took, actual user migration was in fact a non-issue. We had chosen a hybrid cloud, so our existing user base could continue to log in the way they had always had with their same user accounts and email. And even the application, because of the work we had done during the proof of concept, only required minimal configuration changes, no redevelopment to deploy onto the cloud. So everything went very, very smoothly. And so that brings us very much to ongoing monitoring and management. So of course, with the cloud, this is where monitoring gets very serious. Cloud platform means that monitoring is critical. And there's a couple of reasons for this, not the least of which is that cloud platforms, our Montrium Connect platform included, typically have an SLA, a service level agreement, that mandates a high percentage of uptime. Now, in order to achieve this, we were able to achieve this using all of the carefully planned architecture and items that we had done before. For example, to achieve this high percentage of uptime, all components are redundant. Even when you're on the cloud, it's very important to consider redundancy and single point of failure. So all of our servers are provisioned in different upgrade and fault domains. Now I want to take a little bit of time to explain those terms. So a fault domain is relatively intuitive. It's probably what you think it is. It's where there's a single point of failure in a group of hardware. So a typical on-premise metaphor for this might be the networking switch that attaches multiple servers. If that one component goes down, everything goes down. So that was a very key architecture decision that we documented in our configuration spec, was to make sure that all components didn't have a single point of failure. The other point to consider is upgrade domains. So we talked a little bit about being on the cloud and implications of regular updates and how to control that risk. And using the concept of update domains, that's where we're really able to start mitigating this risk. So an upgrade domain is a location where a particular upgrade on the underlying cloud fabric is performed at different times to ensure that not all systems are affected at the same time. So by having these staggered across update domains, in the unlikely event that there's an issue, your services are not down or affected on all systems. You can simply switch between the two. So Finally, we can realize our benefits of the cloud. We have our highly available, flexible infrastructure. It's all qualified. We have our goal of a robust platform. We have all of our technical and procedural controls in place. Our applications are moved, and there has been minimal impact to existing users. And in fact, we are able to achieve some advances that were a pleasant surprise, such as a more secure system than even a traditional private cloud systems using our two-factor authentication. Now, with that, our scalability is achieved through monitoring. However, there's a couple notes with scalability in terms of our lessons learned. Often the cloud is thought of as completely elastic. However, it's important to note that scalability and elasticity are not quite the same thing. So the cloud, particularly Azure Infrastructure as a Service, is built very much for scalability, both vertically and horizontally. Now, those are two different terms. Vertically refers to giving the same machine more resources. So if you have a machine with 10 gigabytes of RAM, maybe you give it 20. Now, horizontally means you simply add more servers to your cluster. And the cloud is built for both of those, and we can achieve both of those. It's important to note that that scalability has been exist. However, there was some serious work done to ensure that that actually happened, because it's not as automatic as often people assume it will be with the cloud. For example, things can auto-scale. However, there's always some catches. You actually have to be able to monitor and do these things on demand as you need. But with that, the scalability was fully achieved, and we met all of the goals of our infrastructure. So with that, I'll move it on to our closing remarks, and I'll hand it over back to Paul.
Thanks, Sam. So first of all, thanks to Sam and Gianna for going through those different steps for us. I think it's very useful to get an understanding of exactly what we had to do to get where we are today. Just in conclusion and some recommendations, there definitely is significant value to be had from leveraging cloud technology, notably in the ability to deploy infrastructure very quickly, whilst also ensuring that we can meet the requirements from a regulatory standpoint. There's also, of course, financial benefits to it, as well as geographical benefits. When we are considering using the cloud for regulated applications, it's very important to define a very clear qualification process, which will ensure that we're able to meet those regulatory requirements, and it's very important, of course, to document that, because you're going to have to be able to demonstrate the rationale for the process that you followed if you're inspected or audited. So that's very, very important. The process really should document all of the activities that are performed not only by you but also by the cloud vendor. So you need to clearly identify what they're responsible for. And remember that you should definitely have those quality agreements or SLAs in place. And then, of course, you need to make sure that you also do regular re-evaluation of those controls to ensure ongoing compliance. I know that we here at Montrium do it at least once a year, where we re-evaluate everything, and we also, for example, request all of the certification reports and everything else, just to make sure that the cloud vendor is upholding their side of the bargain in terms of the different controls that they have to have in place. We also re-evaluate internally through internal audits to make sure that everything is also happening correctly here at Montrium. And so that's very, very important, given the fact that these are shared responsibilities. So with that, we'll conclude our webinar for today. Now, there are quite a few questions in the question panel, and so I won't actually have time to go through those today, but with the team we are planning on sitting down and actually writing out all of the various different responses to those questions from today's session, as well as from the session earlier on in the month. And so we'll be publishing those. We'll hopefully get those out by the beginning of next week, and so we'll send you through a communication letting you know where you can access that Q&A. We of course are also very, very open to any questions that you'd like to send us directly after the webinar, and so you have our email address here, info@montrium.com. You can send your questions there, and we'll make sure that somebody answers those questions for you. So with that, we'd like to thank everybody for your attendance today at the webinar. We hope it was useful and gave you some insight, and probably also raised further questions in your mind as to how you would move forward with such an environment for your regulated applications. So thank you. Goodbye.